Picking up where we left off in the sine and cosine graphs. And we finished number 1. We did finish number 1 in this class, right?
Yeah.
Okay, so we're ready to pick up on number 2. I tend to run you through the same questions every time. Okay, so you should be able to get used to those questions and ask yourself the same questions. First of all, kind of an important question. What are we graphing? Okay, we are graphing cosine. And if you check in your notes, the top of the page, what does a cosine curve look like? It's a big old valley, isn't it? Okay, starts high, goes low, and ends up high. So that's just kind of a quick sketch to, okay, that's what's on my brain. That's what I'm going to have to graph in the end. Let's see. What about center line? What is my center line? What? 1. Remember, center line is the number added or subtracted at the end. It's your D value. So my center line is 1. Amplitude. Except I don't want the negative. Just 2. Hold that thought and I'll get there in a moment. So amplitude of 2 tells us how far up and how far down we're going from the center line, right? Your amplitude is how high and low this graph is going to go from the center line. Now, I said I didn't want the 2 because amplitude is just the absolute value of A. So it's the absolute value of the number out front. So it's 2. What is that negative?
Let's graph.
Yeah, that negative out front is going to mean a reflection. And we're going to be reflecting the graph across the x-axis. Okay, so anytime we give amplitude is a positive value. If there's a negative on the amplitude, that's just going to reflect your graph. Let's see. What about the period? How do we find period? 2 pi over b. And what is b in this case?
0.
No.
1, 2.
Why 2? Yeah. Your b value is the number right in front of the x. So if you look up above, it's bx minus c in parentheses, right? So your b is your coefficient on the x value. So in this case, my coefficient is 2. 2 pi divided by 2 is pi. So last time, when we did on Friday, a full cycle was 2 pi. Now we're going to take that full cycle and we're going to shrink it down. And so 1 cycle has to fit over the course of 1 pi. And I'll help you through with how we're going to do that. And phase shift. Why none?
There's no C value.
Okay, there's no C value. There's nothing added or subtracted in the parentheses, so there's no phase shift. Okay? One thing I did not get mentioned earlier, when we talked about the reflection here, my cosine graph that's normally a valley is going to do what?
A hill.
Yeah, it's going to flip upside down, and now you're going to be looking more at a hill-like, aren't you? Okay, so just, again, it's not even that you have to draw it in there. I'm just trying to give you guys a visual of, okay, this is what's happening. And as some of you learned as you were trying to do number 1, the hardest part sometimes is getting the right graph, isn't it? It's not labeling all the other stuff. It's, oh, wait, what am I supposed to be graphing? I'll be honest. Once we get into changing the period of phase shift, that's the harder part, honestly. But okay, center line. Let's go through and start some labeling. Center line of 1. Either label it right here at the origin or label it down at the end of the left of the x-axis. I don't care which, but one place or another, label that 1. What's my amplitude tell me to do? My amplitude is 2, so I'm going to count up 2 from 1 and down 2 from 1. So up 2 from 1 tells me the highest this graph will ever go is 3. Down 2 from 1 tells me the lowest this graph will ever go is -1. Okay? Enjoy the easy stuff, right? Okay, reflection I can't really do anything with until I'm ready to graph it. Period. Okay, last time my period was a traditional 2 pi. This time we're going to take our graph and we're going to shrink it down into half that space. Okay? When I do this, because I'm just graphing one cycle right now, a period of pi. So what I'm going to do is I only labeled about halfway over. Honestly, you can label wherever you want to with that pi. If you want to take your whole graph and make it pi, you can. I tend to, if it's shrunk down a little bit, kind of shrink it down a little bit so it makes it a little more realistic, I guess. If you recall on Friday, I said we want to break these graphs up into, I break them into fourths, right? So here we have 0 to pi. What's the middle of 0 and pi? Pi over 2, right? The middle of 0 and 1 is 1/2. So the middle of 0 and pi is 1/2 pi, or in other words, pi over 2. So that's me breaking it into the halfway point. And that's something that should be labeled. Now, I also want us to break this into, that's halves. I would encourage you to break this into fourths, which means I need, okay, what's the halfway of the halfways? So in this case, what's halfway between 0 and pi over 2? Or in other words, forget the pi, what's halfway between 0 and 1/2? Yeah, the middle of 0 and 1/2 is a fourth, right? So pi over 4. What's the middle of 1/2 and 1? 3/4, right? The middle of 50 cents and $1 is 75 cents. So 3 pi over 4. Now, I will say, depending on the graph, I always label the end of the cycle. And I try and label the middle. There are times where you'll just see me do tick marks for these others. I don't necessarily label all the pieces. It just kind of depends on the situation. But on the flip side, it's also good for us to talk through this. Okay. We're ready to graph. We are graphing. We have our 4 pieces here. We're graphing a cosine curve. Normally, my cosine curve would start up here at 3. However, I have a reflected cosine curve, so I'm actually going to start down here at -1. Now, I think in terms of quarters. So a quarter of the way through this graph, so I'm starting here at a minimum. Then the first quarter of the way through, I'm going to cross through the x-axis. Halfway through the graph, there's going to be a max, and that max is at the height of 3. The next quarter of the way, I'm going to cross through again. And at the end of the graph, I'm going to have another minimum. Okay? Connect the pieces. Officially, yes, your graph keeps going. So yes, I do try and remember to put arrows on there. Okay, questions I can answer here.
So is on this, is it always on the y-axis? It's always going up and down. Like it'll never go down up. That's my dumb question.
Well, so had this been a regular cosine curve, we would have started up top.
Oh.
Because if you look back at the original cosine curve, a regular cosine curve starts up top. We started down low because it was a reflected. So that's why normally it would have gone high, low, high. Instead, we went low, high, low because it was a reflected curve. Does that help?
Yeah.
Okay.
So will it always be 1 or negative 1 that we start the start of the graph on?
This is at?
Yeah, like.
It will always be whatever your highest or lowest value is.
Oh, okay.
So like in this case, when I counted 2 up from 1 and 2 down from 1, my low and high points are the -1 and the 3.
Okay.
If I had an amplitude of 5 and had to count 5 up and 5 down, we would have been at what? 6 and -4 type thing.
So, and then we just know it's that negative because it's the reflection.
Yes.
Okay.
Mm-hmm. Okay, ready to try another one? I have 3 and 6 picked out on the back side. Not that they're not all good, but okay, so 3. What's my shape? I am graphing sine. What's a traditional sine curve look like? I'm going to say a hill and a valley. Not arguing you, but they're all snakes in some way or another. So, okay. So sine, it starts at the center, right? Traditional one will go up first and then down. A reflected one would go down first and then up. So, okay, let's see. Center line. There's nothing added or subtracted outside the parentheses, is there? So there is an invisible plus 0. So we do have a center line of 0, which just says my graph isn't moving up or down. It's just in a normal spot. Amplitude. 1. Amplitude is the number in front of the coefficient in front of the sine or cosine, the function. So there's no number in front of sine, so it's just a 1. And there's no negative, so it's not reflected. Okay. What about a period? It's 2 pi divided by b. B being the coefficient of x, which is 3. And so 2 pi divided by 3 is 2 pi divided by 3. Okay, guys, we're going to throw in the thirds. So we're going to have to work at this one. It gets a little trickier when I throw in the thirds, but we've still got to do it. So keep in mind that 2 pi over 3 is going to represent 1 cycle. What normally it has a cycle of 2 pi that goes from 0 to 2 pi is now going to shrink and go from 0 to 2 pi over 3. I'll walk you through the steps here. Phase shift. There's a clue. I wrote down the words phase shift for the first time. What kind of phase shift do we have?
Is it a negative?
There's more to it than pi. The formula for phase shift is C over B. Pi over 3. So our phase shift is C over B. So it is pi over 3. Just like traditionally, this is inside the parentheses. That's a minus sign, so we're going to use the opposite. And so this is a positive pi over 3. And this means we will be going to the right pi over 3. So you're going the opposite direction of the sign. Now, if you're okay with that, that works. Something I also sometimes do if you struggle with the phase shift or remembering what sign and everything to use, another thing I will say is take whatever's in parentheses there and set it equal to 0. So if I take 3x minus pi and set it equal to 0, and you solve that for x, that will give you your phase shift as well. Does that make sense? Because I can add pi. So 3x equals pi, divide by 3, and x is pi over 3. I'm not saying you have to do that. It's perfectly fine without it, but if you're someone that struggles to remember, okay, how do I know which sign to use? I mean, it's always going to be opposite the sign, but take what's in parentheses, set equal to 0, and that will give you your phase shift. Okay. Ready to put some marks on the graph? Center line amplitude, piece of cake, right? Center line is 0. Either mark it here or over here. Amplitude? 1. So I am just counting up 1 and down 1. So really just a traditional sine curve here. Okay. Now, when we label this, I'm going to label a little different because I have to think in terms of thirds. Normally I think about my period, and my period is 2 pi over 3, right? So my graph is going to fit from 0 to 2 pi over 3. But I also have to take into consideration my graph is then going to move pi over 3 to the right. So what I'm actually going to do is I'm going to label out to pi, because based on the fact my graph was supposed to end at 2 pi over 3, then I'm going to have to add pi over 3 to it. I know I'm going to end at 1 pi. This is where my labeling goes different. Because if I label into 4 pieces at this point, I'm labeling into fourths and halves, aren't I? But we need to be able to talk thirds. So I'm not going to do the traditional fourths and halves here. I'm going to take pi and I'm going to split it into my thirds. If I split pi into thirds, so here's 0. We have 1/3, 2/3, and 3/3. Or in other words, 1/3 is 1 pi over 3, so pi over 3. 2/3 is 2 pi over 3. And 3/3 is just the pi. Okay? Now, our period is 2 pi over 3. So what that's saying is that my graph, don't think shift for the moment, okay? My graph is going to fit between 0 and 2 pi over 3. Right now, I have 0 to 2 pi over 3 just broken into 2 pieces. So I would encourage you to at least make tick marks so we have it in 4 pieces. So in other words, basically take these pieces and I'm going to put tick marks in the middle so that I have the halves of those. On this particular one, I'm going to opt not to label. However, you could, because what's a half of a third? A half of a third is a sixth. So you would be labeling in terms of sixths here, which is doable, but it's not something I require. If you have these basic labels, I'm happy with that. Okay, because you've gotten some basics in there. Okay, so I'm going to start us off with kind of like a dotted line graph where it's kind of our draft, and then I'm going to shift it. As you feel confident enough, you can go straight to the final answer. But for right now, what I'm going to kind of do is, okay, ignore the phase shift for the moment. How do we just graph this with a period of 2 pi over 3? Okay? So without a phase shift, our graph it's a sine graph, right? So our graph would start at 0. Keep in mind, okay, it's hard for me to, I can't really cover this up because if I touch it, you know. So we're just going to 2 pi over 3, yes? Okay. Whew. Bad idea. I think the paper must have flopped onto the screen. Okay, so I'm just going to 2 pi over 3, yes? Notice between 0 and 2 pi over 3, I have 4 pieces, don't I? So we start at 0. We will max out over the first piece, so over that first little max tick mark. We will cross through pi over 3. We would have a minimum under that next little tick mark, and we would cross back through 2 pi over 3. Do you see that? And so I'm just going to put this in like a dotted line. This is not my final answer. So a dotted line, a different color, you know. Don't make it a solid full graph, though. It's just kind of a rough draft. So this is my graph without any phase shift. Now I'm going to take this graph and I'm going to shift it pi over 3 to the right. How much is pi over 3 on this graph? How many marks is it? 0 to pi over 3 is 2 marks, yes? So every key point can shift 2 marks to the right. Does that make sense? So instead of starting at 0, where would my cycle start? At pi over 3. Instead of having a max above right there between 0 and pi over 3, my new max is going to be between pi over 3 and 2 pi over 3. So move each piece 2 marks over. Hello. We're in the middle of doing some notes right now. You're welcome. Bye. Guidance at the end of class, or when we get done. Or if you want to go right now, go right now. But I don't know. I always prefer you guys to be in here for notes. So, okay. So let's see. I was starting there. This max moved 2 tick marks here. My cross through at pi over 3 is now crossing through at 2 pi over 3. My minimum that was between pi over 3 and 2 pi over 3 is now between 2 pi over 3 and pi. I was ending at 2 pi over 3. Now I'm ending at pi. Everything moved over pi over 3. I'm going to connect these pieces, of course. And that purple is my final graph. Again, the dotted line may or may not end up on yours. I would expect to see it as we are beginners, but as you figure it out, you may or may not need that. Questions there? Number 6 is the other one I wanted to try. Because what is going to freak you out about number 6?
Like fractions.
There's fractions. Oh no. Okay. So let's attack the fractions, please. Okay. What am I going to be graphing? Cosine. Traditional cosine is a valley. Okay. I'm going to go through. I'm going to go through the basics pretty quickly. Center line of -1, because there's a -1 subtracted at the end. Amplitude of 3, because it's the absolute value of the number out front. So that 3 means that's going to tell me how high and low my graph goes, right? What kind of 3 was it? It's a negative. What's that negative mean? It is a reflection. And we will, of course, be reflecting across the x-axis. So my valley isn't going to be a valley, is it? We're going to be doing a mountain this time instead then. Okay, time to attack fractions. Period. What do we do with period? It's 2 pi divided by b, and b is 1/2. So I'm doing 2 pi divided by 1/2. How do we divide with a fraction? Multiply by the reciprocal. So then we're doing 2 pi, instead of dividing by 1/2, multiplying by 2/1, which is 4 pi. So we're going to have a period of 4 pi. So my graph that's been in 0 to 2 pi is now going to be stretched out. So that 4 pi, if you need to write it in here, is 1 cycle of your graph. Phase shift. C over B. And here's the deal. It's not even that you even have to know A, B, C, D. You just have to know the location of where those pieces come from. So what's my phase shift going to be represented as? Pi over 4 divided by 1/2, right? C divided by B. Since it's a positive pi over 4 divided by 1/2, I'm actually going to say negative. I'm going to use the opposite sign, because since it's a plus in there, we know we're going to have to move this graph left. How do I divide fractions? Multiply by the reciprocal. So negative pi over 4 dividing by 1/2 is multiplying by 2/1. Negative 2 pi, or negative pi over 2. And that is going to be a negative pi over 2 going left. Got it? Centerline amplitude. Can you label that? We got the basics down? Centerline of -1. I'm labeling it both places. Label it one of those two places. I don't care which. You got the amplitude figured out? My amplitude of 3 means I go 3 up, 3 down. What is 3 up from -1? 0, 1, 2. What is 3 down? Yeah, -2, -3, -4. A period of 4 pi. Well, I know on the very first graph we did the other day, we used our whole graph for 2 pi. Well, now I'm going to use my whole graph for 4 pi. It's kind of hard to stretch it out, but it really, this is why I'm grading this stuff, because it really comes down to the labeling. That's important. You can have, my graph can be really long, your graph can be really short, and they can both be perfectly right, all dependent on the labeling. I'm going to divide this into fourths, right? What's the middle of 4 pi? 2 pi. What's the middle of 0 to 2 pi? 1 pi. And what's the middle of 2 pi to 4 pi? 3 pi. Wow, some of the easiest labeling we've done all day. Well, I don't know. Centerline and amplitude are pretty easy once you understand what you're doing. Now, we have to think about the I'm debating which way. Okay, so we also have to think about the phase shift, though, yes? My phase shift is pi over 2 left. Do I have pi over 2's on here? I do not. So I'm going to have pi over 2's on here. Where are the pi over 2's? It's the halfway points, right? So basically, if I go in and put tick marks in the middle of everything, do I have my pi over 2's? Yeah. I'll label that first one as pi over 2. Now, because we're going left, I'm going to have to, and this is where I try and say, just try and put an equivalent mark to the left. Try and make your marks equivalent. That's all that I can ask. Now, maybe you can do the final graph. Maybe you need to do the trial version with me. I'm going to do the trial version. I'm not going to do my phase shift yet. Without a phase shift, let's see, what am I doing? A reflected cosine. So a reflected cosine is going to start down here, yes? Keep in mind, what's a quarter of the way here? And that was actually going to be what? Pi. What was the halfway point going to be? 2 pi. 3 pi is 3/4 of the way. And 4 pi is your ending, yes? So this is my trial run. What do I have to do to get the final answer?
Move everything left or left.
Move everything left. How far left? Pi over 2, which is how many marks? 1 little mark. So right here, I was starting on the axis at -4. Now I'm going to be starting under -pi over 2. I was crossing through at pi. Now I'm going to be crossing through at pi over 2. I was maxing out above 2 pi. Now I'm going to be maxing out between 1 pi and 2 pi. I was crossing through at 3 pi. Now I'm going to cross through between 2 and 3 pi. I was ending under 4 pi. Now we're going to end between 3 pi and 4 pi. So those green marks I'm going to connect and make my new graph. And I don't know, maybe you are talented enough that you don't need to make those marks. Maybe you can just draw the graph with no marks ahead of time. I can sometimes, but I'm not going to teach it that way. Because I know some of you will need to see the pieces. Okay, guys. Try all 6 graphs tonight. Yes, we are turning them in for a grade tomorrow. Yes, I'll be willing to go over a few questions to begin class. I'm not going over all 6 problems. Nor am I going over the 5 remaining problems that you haven't already attempted. Okay?